I'm always a little nervous giving a talk for the first time that I've put together, and I was working on this until about 15 minutes ago. So we'll see how it goes. I'm going to have to refer to the screen. I apologize. I'll have to be turning around. Normally I've got my laptop right in front of me. So you are my beta test audience here on this tonight. So when Chad talked to me about kind of talking about fish stuff, I said, well, no problem. You know, I said, I usually have what's called a state of the lake talk, and I go over all of our fisheries data that we collect in a given year, and then what it sort of tells us. And that really didn't seem like it was going to suit this group real good, so I had to go back kind of to square one and pull out a lot of stuff I learned at school, but sort of had put in a shoebox and up on a shelf in the back corner of my mind. So what I'll start with is a little bit of a refresher on what's called the study of freshwater lakes is limnology. It's basically the freshwater version of oceanography. So if we take a look at things, you know, what is a lake? And I'm sure you can all think in your mind what a lake is. Well, a lake is really, you can think of it as the sum of a bunch of pieces. And all together, when they're put together, those pieces form what we would commonly call a lake. But nonetheless, it is a bunch of individual pieces that we have to look at. And so if we take a look at that, you can think of it as to form that picture, that lake. There's a number of components, and in the watery world, there's three that you would deal with. There's the physical components of what makes up a lake, and those things would be things like the shape of the basin, the amount of shoreline length, its maximum depth, its average depth, the substrate complexity around the shoreline, things like that. Secondly, you've got chemical components in a lake. And those would be made up of things like the dissolved oxygen in the lake, the pH of the lake, the alkalinity of the lake, which is tied into the productivity in that water body, dead organic matter, calcium. We stopped at the wayside boat landing down here and saw a rather large use of calcium in the lake. The windrows of zebra mussels, shells piled up along the shoreline. Well, those things, they have pulled the calcium out of the water, formed that shell. The animal died. Now you've got this calcium that's locked up in the shape of a shell, and that's going to exist for, you know, a long, long time in that. It's been taken out of the water, put into a physical form. Now it's going to sit there for a while until we find a use for it, or Mother Nature manages to grind it back up again over the years through wave action. Dead organic matter. If it's living, it's considered part of the next component. But once it's dead, it becomes part of kind of a physical component in that breakdown process to add to the water body and those nutrients that are in there. It's the recycling part of a lake. Then the final component that makes up those puzzle pieces are the biological parts, the living organisms, the phytoplankton in the water, the zooplankton that utilizes that phytoplankton and becomes food for fish. Oops, I got to get advanced here. The rooted aquatic plants, the next kind of level up from that. Insects that are out there, the small fish, the birds, the diving ducks, all that kind of stuff. Those are the biological pieces of that puzzle that we call a lake. And then when you put those pieces all together collectively and in the right order, you get what we commonly would probably picture as a lake. But we all know that a lake is more than the sum of the parts. It's greater than the sum of its parts, because we can't capture in those other components the aesthetic components that we humans like to ascribe to water bodies. And so there's just something about, you can sort of picture yourself sitting out on that dock, possibly with a beverage in your hand as the sun goes down. You sort of feel a stress drain out of you. That's a component of a lake that I can't quantify, but we each know that it's important. But sometimes you get those parts, if they're not put together in the right order or they're not in the right balance, we all know that we can start to have problems. And that's sort of, I think we've seen that, hopefully not to any extent, but you've got the algae that you can see, these algae blooms. or it may take the form of rooted aquatic plants, as we saw, 2 years ago now? So the problem is the lake this doesn't bother the lake. It bothers us as humans and as users of that water body. It can affect the fish, it can affect the other components of the lake, but overall, the lake really doesn't care. So by the time it gets to this point, a lot of times, we're at the crisis stage. And when we get to these points, a lot of times, it's going to cost a lot of money and a lot of effort to clean it up. And sometimes if we wait long enough or things get too far out of balance, we really have no choice but to learn to deal with the aftermath of those problems. Now, thankfully, this is not Lake Winnebago. At least it isn't where I've seen it. But nonetheless, things get out of balance, it causes problems. So kind of a review. Some of this I think you had with a previous speaker, but I think it's worth going over because it sort of sets the tone for some of the stuff. Trophic classification of lakes is based on the productivity that occurs in the water body, or the potential productivity in that water body. And it could be thought of as growth, or we call it productivity. It's a continuum. It's not individual compartments. It's a continuum across this whole thing that goes from oligotrophic, I got to use my things here, oligotrophic down here on this end, which is a very clean, clear, pristine, think of a Canadian Shield lake, if you will, rocky shoreline, gin clear water, very few plants, simple fish community. That's oligotrophic, all the way through to the hypertrophic, which gives you probably that last slide with the girls in the algae there enjoying their day at the lake, where the thing is just so hypertrophic and has so much productivity, so many nutrients, that the lake is almost in a state that we wouldn't call it a lake. So it's kind of as a reminder, just to show you these again, it's a good reminder. Notice the fish and the type of fish. You've got deep water, it's clear, some aquatic plants, but not a lot. The shoreline is relatively not grown over. As you go through that continuum to mesotrophic, you start to see more sediments down in the, let's see, will this one work? See those, you're getting more sediments. Here was the original lake bottom here, down here. Now you're starting to see more and more sediments. You've got a little different community of fish in there. It's getting a little shallower. You've got more taller rooted weeds and emergence sticking out. And then when you get to here, eutrophic, you see that you shifted the fish community. You've got bullheads. You've got catfish as opposed to, say, walleye and trout. You've got aquatic vegetation covering the entire lake bottom. A very productive system, a lot of things going on there. Many times, and I would actually call this hyper-eutrophic. This seems a bit extreme, but nonetheless, a lot of activity going on in there. The best lakes, as far as what we humans would picture and call a good lake, lies in that continuum of the mesotrophic, right down in here. Sometimes the Canadian Shield lakes, they're nice to look at, but from a fishing standpoint and from enjoying them, sometimes they're just not that productive because they can't be. They haven't got that productivity built into them. So mesotrophic is really kind of that middle ground that we like to, I think of when we think of, say, northern Wisconsin lakes. Now, the trophic state of a lake is affected by a number of things. And as you can see up there, you've got the age of a lake. Every lake is born to die. Basically, it will become a bog. It will become land at some point. It just fills in that natural course of events. The shape of the basin, the depth of the water body, the geology of it. In other words, the nutrients that come in from just the watershed, the flushing rate, how fast the thing's carried through that system if it's a flow through, and through human effects. And really, if you look at that, the only thing that we can really affect or change on there are the human effects to the water body and this trophic state. I can't change the shape of Lake Winnebago. I can't deepen Lake Butamore. I can't change the shoreline length of Lake Winneconne. Those are pretty much set. The only thing we can really, as humans, do that affect this is work on the human inputs into that, keeping those lakes from going too fast through that continuum. And we use water clarity and chlorophyll and phosphorus as kind of a gauge of where we are on that trophic scale. Another thing is that remember that a lake is merely a reflection of what goes on in the watershed itself. Everything that happens in that shaded area on the screen is at some point going to affect us. And that's why it's important that we have stormwater or controlling construction runoff in Fond du Lac is important. It's why it's important that stormwater controls are in place in Wittenberg. It's important that manure is properly land spread when you get down around Princeton. And it's also even important how many nutrients and pesticides a potato farmer up near Elko uses. Because in the end, it's all going to end up right there coming out into Lake Winnebago. So our lake is the sum total of what's happening in the watershed. Kind of a review, I think you've had this slide, so I'm going to focus on one particular area in here. But if we look at the parts of a lake, you've got the benthic zone down here, which you could think of as the bottom part. You've got this euphotic zone, which is as deep, as far down as light will penetrate into the water. Okay? And you've got things that are going on over here in what's called the limnetic zone, the open water zone where light will penetrate. You've got algae and zooplankton out there. You've got some of the pelagic fish species that live in open water. But we're going to concentrate on this part right here, this littoral zone. Okay? And that's the shoreline area where light penetrates to the bottom. That's an important part of the lake because 90% of the production that occurs in a lake, and remember that determines its trophic state, 90% of that occurs in that littoral zone. And the basin shape, along with the water clarity, determines the size of that, the littoral zone. So if you had a lake that had a real shallow sloping shoreline, or what would be known as a shoaled shoreline, or it had very clear water, or a combination, the effect it would have on the littoral zone is it would be bigger. And then the opposite would be the same. If you have a very steep dropping shoreline or you have dirty water, that littoral zone is going to shrink. And that littoral zone is really critical to a lot of different species, at least at some point, at least one point in their life. It's critical. A lot going on. It provides spawning habitat for a number of fish, particularly panfish species, and that's what you would call a rather thick bed of bluegill nests. It provides hiding areas, nursery areas, and areas for fingerling fish to escape predation and to hide from getting eaten, basically. As far as spawning, it also provides an area, perch in particular, they have such a unique egg mass, that skein that comes out of them, and that egg skein is neutral. It doesn't float, it doesn't sink, it just kind of bobs along in the water. But to have successful perch hatches, you need to have some vertical things in the water that those skeins hang up on. And then they just sort of hang there in that water. The wave action provides them oxygen, carries away the CO2 and stuff that comes off the egg, keeps them from getting silted up in that. So vertical structure for perch is important at spawning, and usually you will see that with those weeds in the lake, that the perch skeins hung up on those vertical strands, and they don't necessarily, they can be last year's strands as well. So it also provides, it's a food production area. It's a huge food production area. Bugs, scuds, you name it, is going on in that littoral area of a lake. And the fish then will key in on that. Small minnows and that will be in there feeding. Bigger fish come in and feed on the minnows. It's sort of the chain of the food chain, which is, it's a web, but that's a good example. And finally, it can be a living place for an adult fish. It can provide ambush cover and other things for adult fish that also rely on those small fish, and yet they're not just going to swim by randomly. So that big fish needs to needs to have somewhere to hide. And you can always imagine a largemouth bass under a bunch of lily pads hiding in there, or a muskie laying right along underneath a log. It sort of blends right in. It's all occurring in that littoral area. So the littoral zone is really where it's at when it comes to a lake. It's where all the action's going on, and it's also, if you think about it, it's where most of your fishing really occurs. Now, Winnebago, again, is a little bit of an exception with the trolling and that, but if you think about a lot of lakes, say in northern Wisconsin or even southern Wisconsin, if you see people fishing, generally it's along shorelines or it's in that area. You're casting to shore, you're casting to a shallower weed bed, things like that. It's that littoral zone that is really important. So talking about the fishery, I'll kind of shift gears here after that little bit of a Limnology 101 section. You really need two things. If you boil everything down, you need two things to manage a fishery in its simplest form. You need to know about the species that are in that water body and what's going on with those species. In other words, how many of them are there, what is their size distribution, how long are they living, what are their ages, do they have spawning habitat, how do they spawn, where do they spawn, things like that. So that's no various species that are out there. The second thing you need to know in most places, if you don't have angling on the lake, then you don't need this one. I can't think of but a handful of experimental lakes that they aren't allowed to fish on it. So the other component you need to know is what's going on with your anglers and what are they doing to those fish populations. So everything is always kind of in a dynamic state. One thing is up, one is down, both are up, both are down. That shifts around, and it's not static over time. This second one is actually kind of hard to get at, and from my job, it's easier for me to get the information on the fish species than it is on our anglers. And the reason for that is several, but one, it's costly to get it. You need to do, and we normally would do it through a Creel survey, where we would have Creel clerks would randomly work different boat landings with a schedule, random times of the day, weekdays, weekends, and they would interview anglers that come off the lake. And how many did you catch? When did you start fishing? When did you end fishing? How many did you catch? How many did you keep? And we would get all this information through the course of a year. And they do this quite frequently in northern Wisconsin at the treaty lakes. They need to keep a handle on this. You would, through various formulas and things, models, you would generate this picture of what's happening on the lake from the anglers. How many fish are they catching? How much effort is going into the fishing? Everything else. To do a Creel survey on Lake Winnebago is, I don't think I'm going to see one ever in my career. It would be, my guess is at a minimum of $250,000 to do. To have the number of Creel clerks to cover the landings, and you've got airplane time in there to do counts, because you have to do counts to relate this back to, you get a sample of what's going on from a few anglers, but you need to expand that to the whole lake, and that's where these counts come from. Well, another way to count what fishing pressure on Lake Winnebago is from the air. You're not going to do it in a car. You're not going to do it in a boat. And so we're just not going to have that. The other way you do it is you take an educated guess, or you rely on volunteer tag returns, or a swag. And someone's laughing, and I'm going to guess you know what a swag is. Anyone care to share so I don't have to be on the spot? Well, that's right. But in our case, it's a scientific wild blank guess. So if we look at kind of a typical year on Lake Winnebago, and I deal a lot with the walleye population and kind of the general community of the lake, along with other issues, but that's kind of mine. Sturgeon is actually a different biologist. Ron Brook is that, and we've just hired actually Ryan Koenigs is gonna take over and do the sturgeon stuff now. He's a great young guy, and the sturgeon will be in very good hands for his career. But in spring, we want to take a look at the walleye, so we get out with the shocking boats up on the marshes, and we collect information on our spawning population of our walleye, our mature fish. And we basically, every fish that we net off the boat is measured and tagged. We weigh a sample of them. We don't weigh everything, so we get a general idea of average weights of our spawning stock in the different sizes. And then we also actually now have begun, instead of clipping a spine to use for aging, we found that aging fish with a spine is not as accurate as it could be. And so we've actually, the most accurate way is to use what's called the otolith, or another term for that would be the ear stones, if you're familiar with sheephead. The analogy would be some of our inner ear bones. And you have to kill the fish, unfortunately, to get them out, but they are incredibly accurate, and they are the way to go to get the best information. So we have such a surplus of male walleye on the spawning marshes that we usually kill about 250 over the full range of sizes, and then the meat is donated to food pantries, and we get really good information that way. So we only do males in spring. And the reason for the tagging is twofold. We want to look at what's called exploitation, or in common terms, how many fish are being harvested. And then also, in a moment, I'll tell you, we monitor tournaments. So we're actually looking for those tags at these tournaments to get information back. So when in the summer tournaments that are going on, we monitor some of the larger walleye tournaments. We look at the size distribution that the anglers are catching, the sex distribution, because actually of the fish that are not able to be released, they're in too rough a shape, we actually cut those open and see what sex they are, and for females we see if they're mature or immature. So we get a lot of actually very good data from the tournaments, so those fish aren't really ever wasted at the tournament if they're not releasable. We make the maximum use out of it. No, we monitor some of the major walleye tournaments. Usually it's 2 to 3 walleye tournaments and a bass tournament or 2 to get some bass information. No, we don't have enough personnel to monitor all the tournaments, believe me. And then we're also looking for those tags from the spring that we put on. And they're important because we use those to collect. We used to use them for kind of movement studies, but we don't really anymore. The primary purpose of that is to get an idea of the kind of what I would say an index population estimate. And we're not really looking for a point estimate. We're looking at trends to see if the population seems to be going up or down. Then we also collect aging structures from the females at these tournaments, because we have a lot of female. The larger walleyes don't survive bouncing around in a live well. So that's when we are able to get some of the aging information we need for females. And then the main tool we use for out on Winnebago is trawling. And we use that to look for, to get a gauge on how good the year class is of a number of different species that live out in the lake. And we also collect adult or length information from game fish as well as drum. And then anything else that we've got going, we would use to collect out there. It's a handy thing. So having said that, kind of give you an idea what my year is like. I'll give you a very condensed version of my usual talk, sort of the status of where we are right now. So if we look at here, this is the male walleye from our spring spawning stock this past spring. It's a very classic bell-shaped curve right now, with the majority of the males being somewhere right around that, I would say 16 to 17 inches. It's about 9, well, there's probably at least 9 year classes of walleye represented in there. So it's a very good, healthy distribution for walleye, a lot of what I would call medium walleye. If we look at the females, an even wider spread. The interesting thing here is this spike sticking up right here. That's probably some 2008 females that are just starting to show up in there. Some of the early maturing females, and we've got here. There's probably fish ranging anywhere from age 5 out to age 21 or 22 in that female population right now. So that's a very healthy age distribution. It's a good thing to have. If you would just have a couple of age classes in there, that would be kind of a red flag as to, well, what are happening to the other ones. So a pretty good spawning stock of walleye that we have out there. Now I mentioned the tournament stuff. I'm going to leave that out. That's more interesting if you fish tournaments. So I'll skip ahead to the trawling part of it. And a number of people over the years, I always talk about trawling, and I'm so used to it that I remember, well, maybe not everybody knows what trawling exactly is. So I'll give you a primer on that. The main assessment boat, and who hasn't seen that boat out on the lake? Okay, it's been a fixture out here since 1976. It was its first year in service. It was originally designed and built to remove sheephead from the Winnebago system. And it did that in spades until 1990 when we finally ended that program because of cost, and it really wasn't doing anything other than providing cheap mink food for mink ranches. And so we decided to retask that vessel, and we use it for our assessment out on Lake Winnebago for a young of year. And the business end of it, it's a 53-foot trawler. The business end of it is this, and point out the major parts. You've got a ramp that is hydraulically go up and down. There's the net being towed behind it. These are the doors, and they're essentially a planer board, only they're the size of your front door. And they essentially, the way they're hung is when you lower them, they point down and out, and they will take that net straight to the bottom, or as deep, well, it'll take it to the bottom until you run out of cable. This is a roller that the net runs over when it runs up to, and there's a big reel right here that you wind the net up on. And so the way this thing works is the doors are lowered to the bottom, and the net is carried down and is towed just above the mud. So it goes along the mud like that, scooping up everything. Now the trawl itself is 26 feet head rope, that rope with the floats, about 26 feet. So it spreads out about probably 20 feet wide with the bow in it from the water. And we leave it down there, and essentially scoops up anything in its path that's right along the bottom. We leave it on the bottom for 5 minutes, and then we bring it up. So we winch it up onto that ramp and onto the roller. Or the roller then goes up. It gives us some lift. Otherwise, we've got to crawl in there like raccoons and paw the fish out, and I got tired of that. And then the bag is emptied out onto the sorting table. And this is a point where you don't want to have your mouth open. And then we basically begin counting. And everything that comes out of that net is counted by hand, separated by species, and whether it's an adult or a young of year from that year. And you never know what you're going to get. It's like Christmas sometimes what comes out of that thing. We count all of the adult fish. The game fish got priority, and we put those in some water tanks that we have on the boat. And then we count all the sheephead and the rough fish. Most of the rough fish get tossed back over. The sheephead we keep. Those are taken to the front of the boat on a conveyor. And then we're left with our forage fish, or all the little young of year minnows out there. And they do the same thing. We separate those out by species, and it's all hand counted. It's an exact count. We're not estimating anything. The forage, this is kind of the main bread basket for all the walleye and the sauger and everything else that's out there, the northern pike. This is their food for the year, whatever is hatched that year. So it's important to get an idea of what we have out there for them to feed on. And then, so the next bunch of graphs are kind of show where we are. And essentially what they are is they're the average of, we trawl 3 times a year, but roughly the first week in August, September, and October. And then we trawl at 46 different spots all around the lake 3 times during the year. So we make 3 circuits. These graphs show the average number brought up in a net in a year from all of those different sites and by species. So I always start with everybody's favorite, the venerable freshwater drum or sheephead. And the point here is that you can see sheephead kind of bounces around. They have good years, they have bad years, some years they have medium years, whatever. Last year in particular, which will be on your far right for you guys, down here, pretty poor year for sheephead. They didn't have a very good hatch. We look at white bass. White bass had a good year last year. Second best year since 1986, since we've started doing this. They are also up and down, up and down. You can see that there's no real rhyme or reason that you could draw through those. as are gizzard shad. Now, gizzard shad is rather different because we are at the far northern edge of where gizzard shad will exist. You're not going to find them in the Arctic. They wouldn't even do well at all in northern Wisconsin. They're very sensitive to cold, and so they're more of a southern fish. They probably came in through the Wisconsin River back when they dug the Portage Canal and connected the Upper Fox to the Wisconsin River. They probably came through there and actually possibly in some floods got flushed into there out of the river way back. You can see they have boom and bust years as well, and they're the extreme. When they have a good year, they have a very good year. When they have bad years, they have very bad years. 2010, they had a fantastic year. Last year, not so much. The important thing to think about these three species in particular, that's the next one. These three live in that pelagic zone. They live in that limnetic zone away from the shoreline. They spawn out there and everything. They are totally reliant on a good year class with climatic conditions at the time that they're spawning and at those times that those eggs are incubating. So they really don't rely on that littoral zone too much. Yes? Yes. Well, we catch them the first year. That net it has a 1/4-inch mesh liner in the bag. We'll get emerald shiners that are 3/4 of an inch long in that bag. So this is everything from this year already. Mm-hmm. Well, gizzard shad, mature versus caught is two different things. You would, like if it's a walleye, to get a walleye to about 13 inches, females is about 3 years, males is about 3.5 to 4 years, right in there. Gizzard shad, they're ready to go. Basically, they're spawning that second year already. So, but anyway, these are fish that don't rely on that shoreline, so they're kind of a little different than that. They're outside that 90% production area. Perch, or what we call commonly grounder around here, they are more of a shoreline species. They are using that littoral zone and some of the reef areas out here. And you can see their numbers have gone up. Their numbers have gone up fairly well over the last decade or so. And now I'm waiting to see if they're getting eaten at a too high a rate because of the good walleye that we have. Now we'll move into some fish that are absolutely critical relying on that littoral zone. Yellow perch. If we take a look at yellow perch, all through the late 80s and the 90s, not doing so well. They didn't have very good hatches at all. Beginning in 2001, we started to see a lot more bigger hatches of yellow perch. And that really coincided about the same time we started to see better numbers of rooted aquatic vegetation in the lake, and the water was getting clearer. The water was clearing all through the 1990s, really. And I think 2000 is when we started to really see that seed bed in that littoral zone start to take root and actually could grow before the lake got turbid and get some response. And then we started to see our panfish hatches go up, as evidenced with the yellow perch. Now in 2011, even though it was a bad year, remember I said they rely on that vertical structure for their eggs to hang up on in those skeins? My guess is that there was a lot of plant material still left out there from 2009, which was a good year or so. So their skeins hung up on those, and they pulled off a good year class. Because perch spawn would have spawned before that vegetation, that thick vegetation in 2010, they would have spawned before that stuff actually grew. So their stuff is their success was relying on the previous years. Bluegill, another one. 2010, bluegill was off the charts, the number of little bluegill that were out there. And their numbers are increasing. Guys that I know that fish a lot of bluegill are really starting to have some good bluegill fishing and good size of bluegill out there. So again, another one that's dependent on that shoreline critical area. Whoops, I'm pushing the wrong thing. Black crappie, another one. 2010, that Yearclass was also just nuts. And both of those would have been spawning at the time that that vegetation in 2010 was actually coming up. It provided probably super dense hiding where those guys escaped a lot of predation. And the crappie really shows up last year all over the lake, even out in the open water areas, which once those little crappies start to get a little bigger, they can venture out away from the shoreline and into the open water. Their numbers showed up last year trawling with just incredible numbers of 5 to 7 inch crappie all over the lake. You couldn't put that net down without getting crappie. Walleye, I think everybody's always interested in walleye. If you fish or live around this lake, it's what, you know, the Wolf River, the spring run is almost as legendary as Babe and the Blue Ox and Paul Bunyan. They have some interesting things that I want to talk about. They don't rely on the littoral zone of the lake, which is interesting. Our walleye are very different. They run 50 to 100 miles up the Wolf River and up the Upper Fox and utilize some spawning habitat up in those rivers. And they use these spawning marshes, which is, throw the book out on walleye biology. They're supposed to spawn on the wave-swept rocky shores of lakes. Ours run up and spawn in what is supposed to be northern pike spawning habitat. So the way these spawning marshes work is they're very unique, and it's not just standing water that backed up in spring. There's a distinct method to the madness of how these spawning marshes work. And this is an example of a storied marsh on the Wolf River, Spurs Marsh. Essentially, rising water enters a number of old river bayous and cuts and goes onto this spawning marsh area. And as it goes across these shallow flooded areas in the sun, it picks up a lot of warmth and a lot of solar energy and warms. Well, as it's flowing out that bottom end, those fish sense that warmer water coming out, and they follow up and they follow it into the marsh. The males move up onto the marsh first, and this is my classic college bar analogy. Walleye spawning marshes are just like a college bar. The males come in first and stay until closing time. The females come in, pick a guy, and they leave. That's exactly what happens. The females kind of get into it as they feel that warm water. They move on to the lower parts of the marsh. Their ovaries finish developing the eggs that last day or two, that final cue, and when they're ready to spawn, they move up onto that shallow grassy areas, and they spawn with the males, and the eggs are laid up there. The females leave the marsh probably within 24 hours after spawning. They drop back down to those kind of purple areas in the lower, deeper ends. They rest up a little bit, and then they head out, because now they're done with that task. It's time to go get a pizza. They want to hang that feed bag on right away. It's a lot of energy gets used up in spawning. They just swam 125 miles to do this. So, and the males hang around, like I said, until closing time. And we've done a lot of work with Walleyes for Tomorrow and Otter Street Fishing Club and Shadows on the Wolf over the last 20 years to really restore a lot of these marshes. They had become dysfunctional in many places. So some of it might be as simple as signing an agreement with a landowner to close off the spawning marsh to keep people out of it. Mow the brush to keep it in that grass and vegetated state. They don't, it needs to be flooded grass, not brush. We might take a riverbank that no longer is built up and where we're not getting water through where we need to, cut that riverbank down, rock it, protect it so it doesn't erode. And in this instance, we had a little high spot to get back to the marsh where it used to flow. And when you're all done, you have a really nice spring floodway to get water back into that marsh and get it flowing. And on the bottom end, we might take where a landowner built an old dike to build a duck marsh or a rat farm, and we take it so we can get water flowing through that marsh again. We'll put in a structure that'll meet his needs to hold water, still it meets our needs to pass water and track those walleye in there in spring. Kind of to talk about, and I'm behind already. I'm surprised Chad hasn't got the hook out. When we talk about managing a fishery, people think that we have a ton of things that we can do, and there really isn't. It's a very simple toolbox, if you will. There's a few options, and that's about it. We can use fishing seasons. So we can shorten or lengthen a fishing season to control the harvest. We can put on size limits to control what anglers catch. We can put on bag limits or a modified bag limit that would include a size and how many you can catch and of what size. And we can make fish refuges to keep people out of that are fairly common. I'm going to let you in on a little secret. All of those rely on about 98% of anglers following the rules. And if they don't follow the rules, then the final thing that we have is kind of enforcement. It's that the carrot or the stick, basically. When we talk about, I mentioned voluntary versus creel, a creel, compulsory creel. We rely heavily on volunteer angler tag returns on the system. They're critical to what we do and how we manage it. And so it only gives us a minimum estimate of exploitation, because we do realize that not everybody's going to turn them in, but we have run some models and found that we have pretty good compliance with that. And so we're probably running anywhere from 50 to 70% tag reporting, and that's pretty darn good. And so it may only be a minimum, but it's better than that swag. One thing is that I kind of want to point out here is that Mother Nature really doesn't care how the productivity is tied up in a lake. I mean, that's something we ascribe to it. She doesn't care if it's nice clear water with some nice pretty bulrush beds along the shoreline and 3 and 4 pound walleye, or whether it's fetid stinking blue-green algae and carp, because that productivity is going to get tied up somehow. And the reason that matters is because, as I said, we care. We're the ones that determine how we want to try and shape that lake. And I think you heard about the economic impact study that we did. The goal of that was to determine what the fishery is worth out here, and I wondered that for years. And it was such a difficult question to answer. The only way you could answer it was, well, I don't know what it's worth, but it would sure be, you know, a lot of money lost if we didn't have it. If somehow that lake got filled in, or it became totally toxic and poisonous to fishing. Your gut tells you that we would lose money somewhere along the line if that was the case. Property values would tumble or whatever. So again, that study looked at the Winnebago pool lakes and the effects of fishing only has on those 5 counties. And again, it was, you know, $234 million annually. That's not chump change. That's a major thing. 4,300 jobs when you figure the multiplier effect in there. Lake Winnebago would be the largest employer in Winnebago County, in those 5 counties, if it was a business. Or fishing would be, I should say. And the regional impact, these are interesting. Country USA brings in about $23 million in that week it's here. Whitman Regional Airport, non-EAA related, is about $41 million. Port of Green Bay, about $70 million. Fox Locks, if it ever comes to fruition, is projected at $70 million. I question that, but that's another day. EAA, big deal in Oshkosh. Event City, $80 million they bring in. Packers, what could be worth more than the Packers? My God, $144 million to the Green Bay and Brown County. I'll tell you what's worth more. Fishing on the Winnebago system trumps it in spades. That's a year-round money coming in. That's not a shot in the arm 1 week or 6 days or a couple, you know, a number of weekends. It is year-round money coming into these 5 counties. That's new money in essence. Statewide, if you expand that, $2.3 billion fishing is worth to the state of Wisconsin. That's worth protecting. That's a major economic impact. The bottom line is that anything that has the potential to affect water quality or affect the fishery also has the potential to affect the economy. And that can be positive or it can be negative. That's why controlling construction runoff, again, is important. Agricultural practices, important. Invasive species that we're going to hear about in a minute can have major economic impacts. And just plain boneheaded acts by individuals, groups, or companies can all cumulatively affect what we have out here and the quality of what we deem as our lake. So Thank you. You want to do questions now or wait? Okay. Any questions? Yes. Sauger is doing yeah. The question is how are the sauger doing? I kind of left sauger off. I probably should have put them on, but I'm already over my time limit. But in a nutshell, sauger is doing good. We had a project that initially started as 5 years with Walleyes for Tomorrow and Otter Street Fishing Club to try and restore sauger numbers out in Lake Winnebago. They had dropped precipitously about the same time that walleye went down at the end of the 1980s. Walleye bounced back up with the habitat work that's been going on. Sauger numbers remained low, so the clubs came and said, we want to stock sauger. So we finally agreed and said, well, we'll work on it for 5 years. We'll help you collect the eggs, spawn our own fish, because our own fish are the ones we want to use. We don't want to go down to the Illinois River and get sauger and bring them up here. So we did. They set up a portable hatchery in Oshkosh, and it was a great experience for both us in the DNR, and I think probably more so rewarding and educational for the clubs that undertook it. And it was, after 5 years, we looked at it and we said, you know, it looks like it's starting to have some impact, and the clubs agreed to put another 5 years into it. So we stocked sauger in Lake Winnebago for a total of 10 years. And steadily during that time, we started to see the adult numbers increase on the trawler, and on and off we saw good and bad year classes that we picked up. And some of that is environmental, some of it is other things. Bottom line is their adult numbers are pretty good. We've brought the numbers back. The question is going to see is whether they can successfully spawn on their own and continue to keep those numbers up, or whether they would be reliant on us to stock them. And things have changed in Lake Winnebago to where sauger, you know, may not be able to compete as well as a species as walleye, simply because sauger absolutely love dirty water. And their heyday was when we had a lot poorer water quality out on Winnebago, the bad algae, that kind of stuff. A lot more turbidity. We've cleaned up the system. We've got cleaner water, clearer water. Maybe walleye is the thing that's going to outcompete sauger now again. So we're kind of in a hiatus of stocking right now for at least 5 years. We're going to continue to monitor the adult population. We'll get an idea on whether they're reproducing from off the trawler from that young of year assessment, and we'll see how they do, and then we'll revisit that question after about 5 years. Mm-hmm. Another 100 million years, it probably will be. It'll be a big wetland. Every lake, once it starts, you got to think it's a hole in the ground. So what happens to a hole in the ground? It fills in eventually. So I mean, it may take hundreds of millions of years, but eventually the fate of any lake is to fill in. So, yes. Mm-hmm. The question has to do with muskies in Winnebago. We've always had a naturally reproducing small population of muskie in the system. Probably they're a little more prevalent in the upriver lakes, but there's some in Winnebago as well. The trouble is they weren't probably the natural strain that was out here. So beginning in 2001, we started stocking the Great Lakes spotted strain, or Great Lakes strain of muskie, which is also known as the spotted muskie. And that's what would originally have been in the system, because we were tied into the Great Lakes. And we were able to stock and get fish from 2001 through 2007, at which time the VHS problem hit, and the brood stock, unfortunately, to get those was coming from the Bay of Green Bay, who also then, being downstream of Little Lake Butamore, had its own problems and became VHS water. And so we could not get spawn from those fish anymore to put in our hatcheries. So we have since got some disease-free eggs, and they spawned them, and they were put into Archibald, Elkhart, and one other lake up by Oconto. And so we're basically, as a state, waiting for those fish that were stocked to get of spawning age and reproduce, and then we're going to use those eggs to resume that program. But in the meantime, from 2001 to 2007, the fish that we stocked, and primarily in the upriver lakes, we don't go sample them very often, but the times that we have been able to get our hands on some, they're doing pretty well. I'm quite confident that they are reproducing, and I've gotten some reports from guys that I trust, good anglers that know what they're talking about, that have I've heard of 2 fish over 50 inches from the upriver lakes last year, and I'm sure that's probably not the only 2. So I guess the punchline is stay tuned on the muskie. Yes. Mm-hmm. The trouble is you would, to run it year round, I mean, you have some randomized hours to make it statistically valid. So you would need kids out there at 6 in the morning till noon, or 10 till 4, or 2 till 8 or something, and it'd be on a Tuesday and whatever. It's weekend days as well as weekdays. To get that schedule, we're actually going to try and do our own with our staff. We're going to be doing it, and it's going to be kind of a very clipped and short thing to see if there'd be enough, if the data points us in a direction where we would need to have a more extensive creel. And there are other ways to do it. You can do a voluntary, or you can do a mail-in creel where you send postcards out randomly to the people who bought licenses, and then just ask them about the last 2 weeks of their fishing, and sort of you just roll that over and keep it going. But we use a ton of volunteers on the system, and that's one we could explore.